Okay, for the last item for today, we are going to look at why we can rename this course as a course or analysis of vibration. So item number 4 for us today is ODE as analysis of vibrations. In fact, it turns out you need two courses to understand vibrations very well. One is ordinary differential equation, and the other one, your favorite, is linear algebra. These two together are needed to understand vibrations very well. Let me just show you some videos, and then I'll put the links for these things further down, and then you can go and look at them at your own leisure. So first item I will be showing you is this famous case of Tacoma Narrows Bridge, the very famous case, also called Galloping Gertie. Yeah, this is from 1940, when this bridge started to oscillate in wind in a very wild manner, and after a few hours it just collapsed. So obviously we need to know about vibrations so that the structures that we build do not suffer from such a fate. It was actually quite an embarrassment that simply the wind blew and the bridge collapsed. So the structures we build, we typically do not want them to oscillate widely in the environment that they are supposed to exist. So once your car goes over a bump, you don't want to feel a lot of vibrations. You want to have good shocks. If you have big buildings, you don't want them to start to vibrate every time the wind is blowing. So one of the topics you are going to study later on is topic of resonance. Here's an example of that. There are three structures representing three tall buildings, and there is a vibrating pad, and the frequency of vibration is going to change, and we are going to see that these structures are going to respond quite differently to the environment. And it's something that we need to understand very well, because these are very similar to the skyscrapers we build or structures we build. So you notice at that frequency, one of these buildings is vibrating rather wildly, while the other two do not feel anything. This is going through a wild vibration, and the other ones as if nothing's happening to them. As we increase the frequency, we notice that each of them are going to take turn to vibrate in the same wild fashion. So again, I'll put the link further down so that you can go and look at the video in a complete style. Here is another very interesting video. It shows you how the tall buildings vibrate and what you can do to absorb that vibration, something that you have to consider during your design process. So very nice video that I hope you are going to take a look at that later on, where this it's about a 10-minute long video, and it shows you how to model a tall building, and then how to absorb the energy of vibration so that the vibration of the building does not cause fear in the inhabitants of the building. Okay, let's go ahead and so analysis of vibration is something that can be studied by the Newton's formula, F equal to ma, which we said is an example of a differential equation, and together with the material of this class and what you learn in your physics classes, you can understand and analyze a variety of vibrations. Now we took a look at situations where the vibration is unwelcome. Most mechanical setup, you don't want to see a vibration. But the situation is quite opposite. In the case of electronics, you actually want to magnify vibrations as much as possible. What do I mean by that is that when you have receivers and then you want to receive a signal from, say, a radio or a TV station, that is essentially a kind of vibrations that you are trying to absorb, and you are trying to magnify it so that your reception will be best and your communication will be best. So in the electronics, we typically want to make designs so that we magnify vibrations as much as possible. One of the problems in this course is the issue of resonance. We are going to take a look at that, and there's a project in this class. Those of you who are interested in doing some additional work, you can read that, and in case you are interested in doing the project, you can let me know. Okay, in the next lecture we are going to start with very detailed approach to a variety of problems we mentioned in this video, and I hope that you continue along with the class. In case you have any questions, please do communicate with me through email, and I'll do my best to respond to you. Good luck and God bless.